All right, guys, today we're going to be going over a quadratic functions unit 7 review. So let's go and get started with number 1. Which of the following statements are true about the function y equals x squared minus 6x plus 7? Select all that apply. If you don't select every single part of the question correct, it is going to be considered wrong. So let's go ahead and do the first part. Given an equation in standard form, we know that we can find the axis of symmetry. All right, so it's going to be the formula x equals the opposite of b over 2a. All right, we've learned that. So we have to label our a, b, and our c. So b is going to be negative 6 in our equation. So outside of the equation, it's going to be positive 6 over 2, and our a value is going to be a positive 1. So 6 divided by 2 times 1 is just going to be 3. So we can see a is clearly the correct answer choice. Our axis of symmetry is x equals 3. Now, to find the vertex, we take that 3 and we plug it back in. So y is equal to 3 squared minus 6 times 3 plus 7. If you're asking where I got this from, it's just the original equation, but everywhere you see an x, you're plugging in 3. That's it. So let's simplify this. 3 squared is 9. Negative 6 times 3 is negative 18. And we keep going. 9 minus 18 is negative 9. Negative 9 plus 7 is negative 2. So we know our vertex now is the point 3, negative 2, making C our correct answer. Well, I know these questions are about the y-intercept. Our y-intercept is always our C value. Our C value in the equation is 7, so it's 0, 7. So F is a correct answer as well. And we know the domain of a quadratic is always all real numbers. So the correct answer was A, C, F, and H. You would have to select all of those to be correct. Again, all of this was on page 37. The skill of how to do this. Now, let's go ahead and look at number 2. It says, use the graph to answer questions 2 and 3. What are the coordinates of the vertex of the graph? So the vertex of this graph is 1 to the left and 2 up. I know it may be kind of hard to see, but it is definitely there. So that is the point negative 1, 2, which is A. Let's do number 3. Is it a maximum or a minimum? Well, we know that it has a smallest value on the graph, so it is a minimum, right? It's the smallest point that exists. Minimum, smallest, right? Put those things together. All right, pause the video if you need to, but I'm going to keep on going up. All right. So it looks like for number 4, says use the table of f of x equals 2x squared. Over what interval is the function increasing? Over what interval is the function decreasing? So with a problem like this, given a table of graphs, we're trying to figure out what the vertex is and which side is increasing, which side is decreasing. Well, good news, guys. Look at our function, f of x equals 2x squared. They didn't have to give us this. This tells us our graph opens up. This tells us our axis of symmetry is x equals 0. How do I get that? Well, the opposite of an invisible b is 0, right? Anything divided by 0 is 0. And if you plug 0 back in here, what's 0 times 2? Well, 2. So my vertex is at 0, 0. So I know my vertex is right here in the middle. So now what I can do is look at my y values, and I can also look at the graph too at the same time. As my graph approaches my y values from the left, which is x is less than 0, my y values look like they're going down. Let's look at the table. 8, 2, 0. Yep, this is all going down, right? Decreasing. So which answer choice says decreasing when x is less than 0? It's going to be B. Let's just double check ourselves. Do we start to increase as x is greater than 0? 0, 2, 8. Yeah, that's definitely going up, right? And then if we look at the graph here, it's also going up as well. So it's really clearly to see that this is decreasing, and then x is greater than 0 is increase. All right, let's keep going. Number 5 and 6. The graph of y equals x squared was transformed to y equals negative x plus 5 squared plus 7. In order to remember this, you have to remember vertex form, y equals a times x plus 5 squared plus 7, right, is the same thing as vertex form, which is y equals a times x minus h squared plus k. So you notice there is no a value in our original in the equation that we're given, right? So we can assume that it's just a negative sign, so a is negative 1, so negative a means it goes down. So first question, select all the transformations applied to the original function. There is a reflection across the x-axis because it flips upside down. Let's do the next one. Translated right 5 units, well, we need to figure out what the vertex is. Remember, the opposite of h is our vertex in here, so it's going to be -5, and then 7 will stay the same, our regular k. Remember, our vertex is hk, and it's always the opposite of whatever's inside here. I've been talking about this for a while now. So -5 means we went to the left 5 units, so d. +7 means we went up 7 units, which is f. So A, D, F. You would know how to get all of those correct to get your answer, to get your points for that question. So number 6, what are the coordinates of the new vertex? Good news, we already have that answer just by using the previous answer. Okay, if you need to pause it, you can to finish copying. I'm going to go ahead and move on. Number 7. Probably should fix this later. That was too heavy. Let me just do this real quick. Sorry for the pause. There we go. We'll go from here. Number 7, rewrite the equation in vertex form. Name the vertex and the y-intercept. So again, we're given an equation in standard form, asking to find the vertex and put it in vertex form. So in order to do a problem like this, all right, we're going to have to do the step 1, which is find the axis of symmetry. X equals the opposite of b over 2a. So our b value is -6, so again, it's going to be +6 over 2 times a 1, because our a value is a 1, just like in the other problem. 6 divided by 2 again is 3. So just like in problem number 1, our axis of symmetry is x equals 3. What's really cool about this, guys, is we can tell right away that we can eliminate some problems, right? This one and this one, A and D, will never be correct answers. If you notice, our h value, which is our axis of symmetry, which is our x value of our vertex, is not +6. It's actually 3. So C or B has to be the correct answer. To get the correct answer, you're going to plug it back in. So everywhere you see a x, you plug in 3. So it'll be 3 squared minus 6 times 3 plus 11. So 3 squared is 9. This will be 18, just like the last problem. This will give me -9 plus 11, which is +2. So my vertex is 3, 2. The only one that has a vertex of 3, 2 is B. So again, pause the video if you need to. I'm going to go ahead and move over to this question, right? I'm trying to make this video under 10 minutes for you guys, so you have something else to... Okay, well, I guess I'll figure that one out later. So the length of a rectangle is 3x minus 4 inches. The width of a rectangle is x plus 1 inches. Which quadratic function equation models the area of the rectangle? So to find the area of a rectangle, it's just going to be length times width, right? So let's go ahead and do this. So we're going to have 3x minus 4 multiplied to x plus 1. These are two separate problems. I'm going to try and keep them separated. So in order to simplify this, we have to use something called the FOIL method. So it's first, outer, inner, last for multiplying. So 3x times x will give me 3x squared. 3x times 1 will give me plus 3x. -4 times x will give me -4x. And last, -4 times 1 will give me -4. If you struggle with this, watch this video over and over again and just make sure you put FOIL, first, outer, inner, last. That's the order of multiplying. None of these look like this answer, though. That's the issue. So we have to simplify this middle part. We're going to have 3x squared. 3 minus 4, that's -1. So -x minus 4. So correct answer would be, in fact, D. Again, pause the video if you need to. We are at 9 minutes, so we're going to go ahead and switch over to the back. All right, let's go ahead and do number 9. Which is the graph of y equals x minus 2 squared plus 1? Well, we're given an equation and we're given a bunch of graphs, so we obviously have to match it, right? So good news, this is in vertex form, right? hk. So which means we know our vertex. It's the opposite of h, so +2 and 1 for our k value. So which is the graph that has a vertex of 2, 1? Let's start there. Well, the only graph that has a vertex of 2, 1 is 2 to the right, up 1 is letter C. They all go up, and there's not much difference other than the vertex point, so it's easy to assume C is the correct answer. Number 10. Which kind of function best models the data in the table? Use differences or ratios. So with a problem like this, all right, even if we're not at the exponentials unit yet, we can still figure this out. Linear, that means it has to be constant, a straight line. So what we're looking for is, are these values going up consistently the same value every single time? Well, let's just check. 3.2 to 6.4, that's a difference of 3.2. 6.4 to 12.8, what's that difference of? Well, that's 6.4. That's not the same difference, so which means it cannot be linear. In order for something to be quadratic, it has to be to the power of 2. It has to be squared. So are we taking all of our values and are we squaring them? No, we're not. It looks like we're going up by 2.
Please meet your ride in the front parking lot. Giovanni Baker, to the front parking lot.
To the front parking lot. Cool. So glad. Anyway, so if we move it again, this will give us up 12.8, and then this one will be up 25.6. So it's actually not going up quadratically either, right? It's not going up by a square, it's going up by doubling every single time. This is multiplying by 2. So it's not quadratic, but it does have a pattern. Because of the fact that it's going up by 2, we could assume it has a pattern of exponential. So an exponential graph looks kind of like this, right? This is the basic exponential graph. So what we have is a graph that's going up really, really fast on one side and going up really, really slowly on the other side. So it kind of looks like a half parabola, right? Half quadratic. Except our values are going up way faster than a quadratic would, or a basic quadratic. All right, cool. So last question, number 12, go ahead and pause if you need to. That was an exponential. So on the test, by the way, if it goes up consistently by the same number every time, it's linear. If it goes up squaring every single number, then it's quadratic, okay? All right, let's keep going. Number 12, use the graph below to answer questions 11 and 12. What is the rate of change for the interval between points A and C? Grid your answer in simplest form. So what we're looking for is, well, how much do I rise between A and C? Well, here's A, here's C, right? I go up 1, 2, 3, 4, 5, 6, 7, 8. How many do I go over? 2. So 8 over 2, it will give me my rate of change. 8 over 2 is 4. So the correct answer is 4. Make sure when you guys are taking the test that you're actually putting in 4 as your answer for the gridded response. If it's not 4, it's not going to be correct, right? 8 over 2 is not the same thing, even though we know it is. So number 12, is the rate of change greater than, less than, or equal to the rate of change between points A and B? So now I need to find between A and B. To get to A to B, I go up 1, 2, 3, up 3. To go to B, I go over 1. So my rate of change is 3 over 1, which is just 3, right? So let's look at the answer choices. A says the rate of change between A and C is greater than the rate of change between A and B. Well, is 4 greater than 3? Yeah. So A would be the correct answer. Again, pause it if you need to. This is about 13 minutes, so I'm going to go ahead and end it here. I hope you guys do well tomorrow and have a great rest of your day.